Anyway, today's agenda on this course is simple. I first want to remind for the record about how to complete this course and then go actually quite quickly into the topic of today. So how game developing companies actually work. For example, in software engineering methods course, we talk about software companies. In other earlier courses in candidates or bachelor's level, we also talk about software companies. But the game developers are not exactly software developers. There's some additions. There's also some things that are not done exactly the same way. So today we are going to talk about how game developers actually work and what sort of things they take into account, for example, when they are designing their products. And finally, at least one person submitted me their tutorial projects and the game plan. Was it you? Yes. Okay. So
I'm working.
Okay. So, but I also know that there's at least 8 other people who are not here today, but who have enrolled for this course. So I'll just go through your game design plan, but we'll talk about it privately. We don't need to record it here. So the quick reminder for those of you who are following this presentation from online video later this week or at later occasion, the idea was that we have 2 tutorial projects and then we'll do our own work. So the tutorial projects are available from the Unity website. There's actually, in addition of those tutorials mentioned on that web page, there's also a couple of older tutorial projects for the older versions of Unity. If you want to use them, you're free to do so, but they may include information which is no longer updated, or they may not include all the newest features and other things of the newest Unity engine's abilities or features. And especially important is the fact that when you are done with the tutorial projects, you should demonstrate your work to me and draft your own personal project documentation. The game documentation, which I require or review, includes some general aspects like theme, characters, genre, features, story, and technical decisions. So it's not a rocket science, unless your game is about rocket science, but anyway, some basic aspects. And like I said on the first lecture, your personal project should be something fairly simple, because the idea is that after this course you are able to participate on the Game Jam Code Camp next January, which is the first course where you are actually tasked to do something. Okay, so the design restrictions are still the same. Everything should be self-made or bought from the asset store or public domain or something like that. You are not allowed to use any illegally acquired assets, so you have to have license for all things you use on your project. That's simply because they are basically university project works. We might use them for some promotional purposes if they are good enough, or at least put screen captures or screenshots available somewhere, and it would be really awkward if there was something that was actually not licensed for you or us to use. Anyway, these things are more or less the same. One thing I should point out, for the audience, both present and online, that the second follow-up day is also set. The first follow-up day is today. After this brief reminder, I'll go to the actual talk of the day. But there's also the second follow-up day, which is in 4 weeks. Or is it 3 weeks? Well, anyway, at the end of the month. There will be no presentation on the second follow-up day because I calculated that there should be at least 5, possibly up to 10 reviews or presentations for personal project, so we will not have time for anything else besides just that I'm going to go through and accept your works. So if you want to complete the course, you should show me something on the second follow-up day in 4 weeks, or if you are unavailable that day, then you have more or less a bit less than 2 weeks for deliver your work via email and arrange some option to meet me. The deadline for delivering tutorials is on 8th of December, and the deadline for delivering personal project is 19th of January next year. That's 1 week before the Game Jam code camp. So the idea is that you don't have 2 things at the same time. This is wrapped up before the Game Jam starts. Okay, so submissions to me via email. Don't send the entire Unity package. It's tens, if not hundreds, megabytes of data, so it will completely destroy our university's email system. Put it available online somewhere, or take it with you on a memory stick or on your laptop and come see me on my office. And here's the brief list of things to do. So most of the people this talk or brief reminder is aimed to are on the 3rd step right now. I have had email enrollments, and now I'm just waiting for you to design for your own game design and some form of contact to tell me that that you are still doing the work. I will start sending reminder emails after this lecture, so that's also something. And of course, well, if you have presented your work to me on before the second follow-up day, of course, you don't have to be present here, just watching other people present their work. But anyway, to the actual topic. So the first follow-up day is about making games. We are making games on technical level with Unity, but there's also some things that you should take into account on game development. Of course, the old idea of software, old objectives or traditional objectives of software development, that we have to have things in time, in budget, with acceptable quality and all the required features, of course, is true also for games, because we have limited budgets, limited windows for launching our products, and also we want to have acceptable quality and all the things we promised our games will have. So actually, there's wealth of common features between software development and game development. They are sort of a cousins in a sense that the games are, for example, designed quite similarly, or the concept of designing a game and designing software are somewhat similar. Also, the development from the programming aspects or programming tasks, or in general on the technical side, the development work is similar. Programming is programming is programming. So with games you do software development or programming tasks, for example on C# or JavaScript if you are using Unity. You might as well be also programming something else with C# or JavaScript in software engineering. This also means that the tools are somewhat similar. For example, the integrated development environments, .NET environments, or Visual Studio software suite are something that both sides use, and they're basically anything related to programming is actually the same. Also, the concept of testing. So we do software testing. Actually, we have to do software testing to ensure that the customer gets all the requirements fulfilled, or that all the required features actually work. But also, well, with games, it's the same thing. We want to ensure that our product fulfills the needs of our customer, or, well, not exactly needs, because no one needs game in a sense. People are using games as a form of entertainment, so instead of seeing if the game actually functions as it's intended to, well, we should be testing what sort of a user experience the user gets from playing the game. Is it entertaining? Well, and also entertaining in a sense that if we are building something that's scary, for example, horror game, of course it shouldn't be a laugh riot to play the game. But does the product give you the intended user experience? So horror games are kind of scary, action games are kind of adrenaline inducing, or some comedy adventure game actually makes the user laugh, or people think it's funny. Also, the objective, like I said, that everything should be in time, in budget, with the intended features and with acceptable quality, of course, are the same. We do software development projects similarly as we do game development projects. And we start from the design, we implement something, we test that it works, and we try to achieve everything in time, in budget, with the intended features and acceptable quality. Of course, this is only one side of the story. There's also differences when we go into the actual software and game business. For example, like I said earlier, the games are products that are not used as a tool or as a system which enables us to do something. They are a form of entertainment. You don't try to enhance your performance with games. For example, with spreadsheets, Excels, websites, or online banking or online shopping, you try to have more options for what you can purchase, or have more access to different products, or access to different services, whereas with games you are not trying to have more processed orders per hour, or more produced parts per hour, or larger catalog of products from which to choose. You are trying to entertain your users. So, of course, the emphasis, therefore, has to be on the customers and on the market, because we are not solving a problem. We are designing an abstract construct which we try to give the customers so that they would be entertained. And if the customers don't like the game, there's no value in the product. If the customers don't like the new net services of tax office, they may complain, but they still have to use it. So in that sense, if we are designing a web service for reporting our income tax or something like that, the customers don't necessarily have to like it, but they have to be able to insert certain figures, and we have to have certain features so that we know that it was actually the one customer who, one person who gave their own personal information. Also, of course, the web service portal of tax office doesn't have to be very artistic or look very pleasing. Also, if we consider something like a word processor, Word from Office, or Writer from LibreOffice, for example, they don't have to look nice. They have to be able to allow the user to manipulate their documentation, or if we are designing something, some software tool to create these PowerPoint presentations, we don't have to think about the artistic vision of anything, really. We have the sort of a theme set up for you from the operating system, but with games we also have to have design with artistic vision, genre, or are we trying to do something modern or gothic or fantasyland or whatever, which also of course means that the development team have to have graphical artists and have to have someone who's actually good at that job. So we also need other people in addition of engineers on our work. And of course, since there's people who have to create graphics or 3D models or stuff like that, there's tools for that work. I honestly don't remember when was the last time I needed 3D modeling tools for other software project which wasn't on games. Of course, if we are designing a new engine or plane or house or something like that, we use 3D modeling tools to create the blueprints or at least create the sort of a preview of what the thing will look like. But that's really small scale use when compared, for example, to game development, where everything is 3D objects. So you have to have access to edit or manipulate or finalize those models. And those use tools which are not as common in engineering world or software development world as people tend to think. Also, on the testing side of of course, with software development, there's automated testing. We can run unit testing or interface testing or module interface and protocol testing with automated tools. There's also many testing approaches or testing phases like unit testing or integration testing or system testing and so on, which test the technical proficiency of the developed system. Of course, these are not as important for games. The important part is that we have to do testing with users. We have to take the stakeholders, the interest groups, the target audience, and use them to understand or have the information that what sort of things our target audience likes, so that we can test if our product fulfills their desires or if it matches something that they would like. Obviously, since if we are not helping people solve any problem, we are giving them something to do, something to waste their time with, so to say. So we should see or test that actually our design decisions do that. On one example project, I personally know, actually on the last stages of testing, one bug left a feature on the test product which the users liked so much that actually the entire game was scrapped and all the levels were redesigned to use that feature. The feature was that basically it was a platforming game. The idea was to test if the audience likes the graphical style of the game, but there was a physics engine bug in the system, meaning that the player could also run up the walls, for example, or stick to the ceiling and stuff like that. And on that context, it actually sounded plausible or understandable because it was more or less a giant wheel in which a mouse was running inside. So the wheel, because of a bug, could stick into the wall or ceiling to some degree. And actually the test users liked that feature so much that the entire game was basically redesigned based on that bug. And it was a true problem. It was one missing tick on the physics engine settings, which meant that on doing this activity, the entire game was completely redone. Also, well, going into the other differences, the sound design. If you are building a web store, you might need some warning sound or something if customer is about to do something stupid, but that's really that really doesn't require any design. But on the games, well, sound design actually plays quite an important part, especially on these AAA highly expensive game console releases. For example, for Battlefield 2, the sound design department had more than 30 people involved because their task was to basically create a simulated war zone where every sound chafing of your uniform against your bulletproof vest or the clanking of your assault rifle when you are running and stuff like that had to be created. Also, designing the environment so that if you were playing a character without helmet, you would have different sort of surround sound that character who had the helmet on or the ear protection and such on, and if you were using surround system or headphones and stuff like that. The guy involved or who was supervising the work gave a 1-hour speak about all the different things they had to do to capture all the sound effects, and they barely scraped the surface of the topic. They showed something about the sound design and stuff like that. Of course, that's not necessary for all games, but of course it means that with game development, you might end up doing something like this. So if you are designing games or developing games, you might find yourself with a busload of volunteers on the abandoned Swedish military base, sticking microphones into those people who are using a customer grade or discarded military surplus items and running in forests and against buildings and capturing all the different sounds of the equipment clinking and clonking and shaving against grass or gravel or buildings and stuff like that. They actually said that was most war games activity that military base had seen in the last 100 years. They rented the old military base for a couple of months so that they could use it also as a sound stage because, well, it was a huge place with no one else there, so it's much more convenient than trying to cram yourself into a small studio in mid-Stockholm. Anyway, also there's development aspects like real-time client-to-client systems, so you have access for several people who are able to see each other on the game. Of course, there's possibility for many people to use the web store, for example, at the same time. But if we consider something like World of Warcraft, where several, if not hundreds of people can at the same time see each other and see what they are doing, and it happens in enough real time that basically you can have a fight against any other player you see, that's of course something that's unusual technology. Or something that's not as used in software business as, for example, in games. Also artificial intelligence and 3D mathematics. Like I said, the 3D mathematics and 3D models are not that common in software development, and the artificial intelligence here means not the sort of intelligence like, for example, Amazon.com or Google search engine systems have, so that they can build a profile about you and see what sort of things you like and do this sort of profiling and guessing work or artificial intelligence in a sense that how, for example, some military systems are, like guided missiles, are able to follow the objects, even though they basically don't know anything else, but they just see something that they were told to follow and they fly after that one. But artificial intelligence in a sense that they emulate or try to simulate the player kind behavior, for example, playing an opponent on a board game or being your enemy or opponent on a first-person shooter or something like that. And also, finally, the objectives. Okay, so the product has to be done within budget, within schedule, with the acceptable quality and all the features. But finally, is the game fun? If it's not fun, or if it doesn't provide the required or desired user experience, it isn't good product. If the game is dull, it's not good game. Okay, so at least you saw this slide yesterday. So this is for you. This is somewhat of a reminder. But actually, if we go into the processes of how games are developed, of course, there's two main approaches here. The pipeline and iteration. These are collected from, well, software companies we have been working with. They are sort of generalized models on how games are developed. The pipeline model starts with the brainstorming or creation of game idea. It means that we generate tens, if not hundreds, of ideas which might work, and then internally vote or have a discussion of what could work as a new product. Those which are promising are developed to proof of concept prototypes, which may include the main features of the product, a couple of drawn models or ideas of what the game should look like something like it's a business simulation about selling hot dogs with ninjas or something like that. And then when you have the prototype, you try to sell your concept to a publisher or funder, or if you want to use internal funding, try to convince your upper management or steering group or board of directors or whoever that this will be the next great thing. When one prototype or proof of concept is considered so good that it should be developed into a product, or if the concept is sold to a publisher, we are talking about this arrow here, then we start the actual development. We go through development and testing and feedback loop several times with the idea that the prototype, which was designed here, is then realized or made into a functional, high-quality product by going through this cycle as many times as it takes. When the testing work provides that the prototype is something, the product in development is something that has all the features and it seems to be functioning correctly, then it goes to acceptance testing for publisher here. And if the publisher says that, okay, it's good, we like it, then it's launched and it goes into the maintenance, which means that there's updates, bug fixes, additional content, and so on and so on. So basically, it might look like a waterfall approach, but technically it's, something bit more different. It's highly iterative here. We are talking about, at least 20, even 50 iterations. Weekly iterations, or even daily iterations to get everything correct and then go to approval. So the other model, the iteration here, this larger picture here, depicts the same idea or approach, but with the difference that we don't get rid of the commercial or the economic aspect. On the first model, the A, pipeline, before the development work started, the team got at least some sort of a confirmation of economic feasibility by having external publisher or funder or the board of directors saying that, okay, the prototype is good enough, we go into development. But if we are a smaller company and we don't have publisher, or we don't want to find one, or whatever the reason, the entire development starts with game idea. It's here. It's basically the same idea with get this done as with the game idea, ideation or brainstorming, but the team selects or devises one idea they wish to take forward. Then they make rough plan on how the product should look like, do development work to get something that's demoable or at least marketable. Based on their experiences, refine the design, test that, okay, now the system should work, and then they are on the decision point. On this point, they collect feedback from any source they can get. Test users, test players, website reviews, possible publishers, and so on and so on. And based on that feedback, they make the decision if they want to go again into the development. Or if they were unable to sell their game, then they go back into the rough plan, do development work, refining design, testing work, and go back here. So basically, they go to this stage and collect more feedback and go through the rough plan development, definition, and testing as many times as it takes. If they get if they get feedback which indicates that no changes are required, or for example, publisher comes in and says that, okay, we'll take this into our product portfolio, then they are done with the product. But the important difference between these models is that the iteration model, more or less starts with the idea that we want to make a game. We don't know if it's commercially feasible. We don't know when we will get money out of it, and it may take a long time, even before the product or project becomes profitable. But the idea is that we keep working and working and working until we are satisfied with the product and want to put it available, for example, on App Store or somewhere else, or try to sell it for distribution via Steam, Steam client system or something similar, or we find a publisher willing to take a risk with the product. It means that with this plan, you always have a product in works, and you just try to enhance and refine it until it's ready for publishing. Whereas here, you just run through the proof of concept line so many times that finally someone says or gives you money or makes the decision that, okay, this one we will finalize. It also means that on the B model, the genre or type of game or basically anything can change based on the feedback, and it may mean that the medieval times platformer may find itself being a Stone Age strategy game or something like that. Okay, so I have spent the first 35 minutes on these things, so I'll try to pick up a speed a bit. So, like I said earlier on the testing work, so in software industry, the testing work focuses on finding the technical problems and ensuring that the software does what it's supposed to do. So it's a verification and validation. Verification that the that the product does what it's supposed to do, or what the documentation or plans say that it should be doing, and validation, meaning that the product was built correctly. So it solves the problem we were trying to solve in the first place. However, in games, the focus is on user experience. Of course, the technical aspects, like does the game run, for example, on mobile phone platform, or if the game works on a video game console, is important, because if it doesn't work, then you are completely screwed. But it's not the main point. Good enough is enough. If it runs rather nicely, only sometimes may slow down a bit, or if it's a bit jagged around the edges, but it's still functioning mostly as intended, it's good enough. You don't spend time on technical aspects like refactoring your code or optimizing your system unless it's causing problems with the user experience. Basically, it also means that besides this user experience testing, there's also content testing. So, because all the requirements and the mechanics and systems are abstract construct, meaning that they are not based on real-world requirements, we also need to test that the internal logic, the features, or these sort of things actually make the game interesting, or at least playable. There should be no always wins strategy, or some way to cheat the game, or if there's a spell basically saying that I won for the first player who gets to play that spell, or if there's some combination of abilities which make the other contents completely irrelevant. These things are actually aspects that need to be tested. And of course, this is something that's fairly alien to anything in software development work. In software development work, since we are just solving a real-world problem, it's enough to just ensure that you solve the problem, and by getting the correct input, if you get the correct inputs, you get the desired output. For example, your system can access the database, do the necessary manipulations, and then insert the correct information without breaking the database they are using. With games, you have to do play testing to see that the internal logic and the features for the game actually work, that there's no some way for the player to make the game completely irrelevant, or if there exists one, it's hard enough to find, or it requires enough labor that it's not completely obvious how you should play your game, and then miss most of the game content. Also, the most usual ways of doing testing work for all these things, like listed here, are user testing. Where's the mouse? There. User testing, meaning that you test with the users. Usability testing, meaning that you test the user interface. Is it intuitive enough? Is the tutorial explaining everything? And so on and so on. Since with games, you really can't have extra training lessons for your players or users. If you are selling software suite to corporation, you can also sell a week-long course on how to use that software. But if you are selling games for iPhone, you really can't sell a course on how to play the newest Civilization game on that system. If the user interface isn't intuitive enough or self-explanatory enough, then it's a failed design. Also, something like explorative testing, which more or less means that we try to use different ways of using the knowledge about the platform or the game or any internal mechanics or any idea on how this system could be exploited to break the game, and at the same time do sort of a play testing with people who have never used the software before to see, for example, that if anyone can use the software or use any feature we want them to use. Also, this includes things like if you know, for example, that the random number generator on some platform is not exactly random, or it tends to give really uneven results, you try to game the system or cheat by trying to use that information as your benefit and try to, well, like I said, try to be creative with breaking the software. It's exploring different ways to abuse or break the application you are testing. And finally, of course, unit testing, meaning that if you do programming work or code something, you obviously should ensure that the basic sanity tests work. For example, like that all the branches within your module actually compile, or if you are using interpret language, that all the branches inside your module work, all the different variations of protocol are actually supported, that everything else functions correctly. So, on the tool selection principles, I mentioned that there are same tools and there are different tools for developing games and developing software. But here are some ideas on how these tools are selected. Well, first of all, there's no separate design tool. Usually, game companies select their tools so that they allow easy prototyping or do designs with less than complete systems, meaning that if you want to test out character model running or the character controls, you can design a level of flat surface and then just walk around with the character there. It means that the tools or environments or platforms should allow easy prototyping and the ability to test things out while you are running. Or running the software or using the software. This also means that things like Visual Studio are completely normal game development tools, but for example with the Unity there's own editor software and stuff like that, but well, they are more or less just normal source code editors. Usually the problems which the game industry people mentioned about their tools, or if they would need something, they said that some of those things are highly unstable, or that there are user interface problems, meaning that you can't find the features and things like that. Also, the different sorts of formal project management systems and stuff like that don't exist unless we are talking about a group size larger than 10 or 15 people. Because on smaller organizations, there's one who's really good at a couple of people who are really good programmers, a couple of people who are really good artists, a couple of people who are really good at selling things, and one or two people who are really good at spotting errors or testing out the internal logistics and internal logic of the system, for example the game rules like I mentioned earlier. With small group, everyone has sort of a defined role and everyone knows what someone else is doing. They are usually also working in an office which is usually not much larger than this classroom here, so they don't need any formal project management system. Of course, if they are running a huge office, then they tend to need one. And for example, if you are working for a publisher which use the abbreviation MS, but we'll leave that unnamed. Otherwise, for example, they make, for example, video game consoles. They may require things which are based on formal project reports and stuff like that. So for publishers, you have to give some sort of documentation or formal project plan or stuff like that. But if you are doing self-publishing work, or your publisher doesn't care about how you got the game done, as long as it's done in time, then you usually don't follow, at least you don't follow anything really complicated or complex system. Also, finally, one myth about the games industry, which probably comes from the, well, from 10 years ago, from the 2005, 2004, is that the case our case organizations and almost none of the organizations they knew about did not apply self-made tools. So there was a period in game industry where you had to have your own tools for doing editing work or development work or anything. If you wanted to create a game, you basically had to start by making your own engine and then making your own level editors and making your own data types and stuff like that. But the standardization and platformization or standard availability of standard platforms or standard development engines over existing platforms are so common nowadays that basically no one ever anymore made their own tools. If they need a new tool, they just buy a plugin for example, Unity or Lime.js or whatever platform they were using. So that was just a waste of time. So basically, what it says that if you are making your own game, there's 10-year-old books say that you should start by making your own physics engine or physics library and 3D engine, but that's no longer necessary. Then, well, the business logistics, these are something different than, for example, on software development. On software engineering methods, the course, I usually talk about projects. So you get a project, you complete the project, and based on what you were doing, you are paid by your customer for the development work, or you more or less have some sort of deal that you are making this feature or this tool available for some one company. Of course, with games, it doesn't work that way. Even if you are talking with a publisher, you usually get only a percentage of sales, or you got a percentage of sales. Because this slide here, even though it is completely true, is already a bit old information, because this talks about pay-to-play models. The free-to-play model is completely different from these, but the old pay-to-play models, like depicted here, used to work this way. So let's consider that you are selling a video game console game, and you want to put that game box available on for example, Prisma, the local supermarket outside the city center. So you are the developer. You get 10% of the money because you sell your work to publisher, who then has a deal with the distributor, who then distributes the game for the retailer, which here in this case is the supermarket, who takes a cut on the profit. Meaning that if you buy a 50 euro game, the developer gets 5 euros out of that deal, because the publisher, distributor, and retailer all have their own take before you get the sale. Of course, it's somewhat fair because the distributors are the people who are actually doing all the logistics. The publisher is the one who paid for all the marketing and also probably the one who paid for the DVD cases and all the graphics and graphical boxes and stuff like that. So it's, well, of course all the development work was done by you, but you just more or less sent your work to publisher who made a nice box for your game, who then put it all and made some ads for it, and then the distributor took the game boxes and shipped them worldwide, and the retailer is the one who is selling your games out from their stores. This was the old way, the traditional way. With the digital distribution, for example, something that the App Store or Google Play and similar things are doing, also, well, of course, Steam on the PC side, and of course they are actually, now they are much bigger venue for selling your games than the traditional boxes. But the idea is something like this. The developer gets 70% of the money, and the retailer who manages the digital store gets something between 30 and 40%. Of course, well, it's fair share or fair game because the retailer is also the one who has to maintain the server farms and the cloud systems and stuff like that. But well, in reality, there's also one additional person, the marketer, the ex-publisher, the ones who run the marketing campaign and the ads and get you net visibility, who usually take also 1/3 of the money. But it's still 1/3 of the money to the developer, and it's 20% more than earlier. So it's easy to understand why all the developers were really pleased with the digital distribution. Well, however, like I said earlier, these are the pay-to-play model ways. It means that the customer pays for the product before they get access to the game, or they are just playing some limited demo before they get to play anything. Of course, with the free-to-play model, the system is completely different. Of course, the digital distribution is the only way of doing a free-to-play model. And there's also, well, there's a couple of things there. First of all, you might have some deal with the retailer on the amount of downloads, some sort of compensation for giving the game freely available through the system, or at least the retailer is managing all the in-app purchases so that they get their slice from the money the people are putting on your free-to-play game when they are buying the diamonds or elixir or liquids or whatever. But then, if we go into the actual numbers, these are collected from, well, several studies and confirmed by our own research into the topic with game companies. So they do not depict any actual game, or well, at least one number is taken from the sales of actual game, but they are just general numbers. So you want to take the full share of 70% from your game you sold in App Store. Well, it's not a good idea, because if you don't market your game, it gets lost in the store, so to say. There's 10,000 applications released in App Store every day, or at least was at some point. So if you don't market your game, or just use your own website or Facebook or whatever, on one scenario, you got profit of 74 euros for the entire game, which took 3 months to develop from 4 different people. So, quite crappy deal. Well, the same company made another game. They made a marketing deal. No money down, a percentage of profit to the advertising company, which is also quite large publisher, a digital publisher. And the game made more than 25,000 euros on its first month. So it made all that. That's actually the profit of the game. So it means that their game paid all the development salaries, paid all the rent, and so on and so on during basically the first month of being available. Of course, it was also a minor hit on one particular market, but still it made a killing, so to say. Not enough for you to, well, reserve your own seat on the first private space flight, but probably something that keeps you fed and warm during the winter. Also, well, the idea is that you have to get into the top 25 or top 50 lists because that's easy visibility and easy advertising for you. Worth of being in top 25 in your own category, for example in App Store, is around 5,000 euros per day. That means that if you are in your own category on top 25 on the first page of the list, you get extra 5,000 euros in sales for each day you stay there. Also, well, the mobile games, if you are working with competent professional team, it means that it takes 3 to 6 months to make the initial launch. Of course, if you are running something like a free-to-play game, you also have to provide new content and so on to keep players interested in your product. But still, it means that the first version of your client takes at least 3 months to make. So, you use half of your year to make a game, and then you put it on sale. If it's a free-to-play game, you have to understand that only 5% of your customers ever pay any money for your product. So for one customer who buys your in-app purchases or diamonds or liquids or whatever, there's 19 players who play your game, actively even, but still never give you any money. Or they may mistakenly or by accident or just one time purchase something. But they are not revenue source because they might just give you €1 or something like that. And out of these 5% of customers, it's 10% of the 5%, so it's 0.5% of the customers are the so-called whales. They may spend tens or hundreds of even thousands of euros on your product. Actually, one guy on Supercell said that there's a person in Singapore who has so far paid over $30,000 on Clash of Clans, simply buying the diamonds and doing all the other things to keep himself in top 10 position in the Singaporean local list. So if you are a multi-millionaire, that's, well, really nothing for you, but still, you want to keep those customers. But anyway, you get 5% of your customers pay you something, and 19 out of 20 just play your game. If you are doing pay-to-play, 90% of your sales come within the 1 month from release. So it means that if you are doing pay-to-play, you if you aren't on green after the first month of sales, you will probably never be making profit on your game. Also, well, by default, this is international business, so you can't design your product so that it's just for the Nordic countries or just for the USA or something like that. You should always design your product for international business, because that's just what the platforms and companies want. And overall, well, the worldwide markets for games, at least on 2012, were something like 65 billion US dollars. The Finnish companies were quite small at that time, actually. These are 2012 numbers. So, for example, in Finland, we got 250 million share of that money, but I'd venture a guess that it's at least over a billion now, because we have the Japanese mobile phone company, for example, bought Supercell for more than that amount of money, so it has to be a larger number by now. Overall, in Finland, the games are about 2,000 employees in about 200 companies. So it also tells you that if the median for company, the development team size in software development was around 30 people, in games industry the size of the company is usually around 10 people. So you are also working with smaller teams than in traditional software business teams. Okay, so a couple of more slides about the different things to take into account when you are designing a commercial product. For example, this is also a bit old information, but this is from 2011, but the numbers here haven't changed that much. So they more or less are still the same. But anyway, the games are not something that's restricted to males or underage teenage boys or something like that. In fact, actually, the average age of people using money on digital entertainment or games is 37 years old. And almost half of those people are female. And that's because the media says that, okay, the people playing games are always the teenagers fondling their smartphones, or some shut-ins sitting in front of the TV, or someone playing a marathon session of World of Warcraft or StarCraft or something like that. They really negative stereotypes. But actually, one of the largest groups of players, the game players who purchase stuff, are around 30-year-old women staying home watching their children or small babies. The babies are unpredictable. They sleep, they poop, they eat, and on irregular intervals. So they can't go anywhere. They have to stay home. But when the baby is sleeping or just randomly idling or doing something else, you are free to browse internet or go to Facebook or play games there. If you allow people on those games to do in-app purchases, they will spend money on it, because people have short attention span or they get frustrated. And if you at the correct point say that, okay, for 10 cents this problem goes away, they buy it. And that's how you get money from those people. They want to just play stuff, collect the pies or diamonds or candies or whatever, and they just want to play for the couple of minutes before the baby wakes up or starts to yell again or doing something else which requires their attention. So that's one group of people who are really, really large customers for games. Also, well, all the other areas of life, more or less. There's always people playing, for example, casino games or something like that, even though internet casinos are not involved in these numbers. But people still play card games or board games or stuff like that, and if they get the digitalized version, they probably like it. So you are doing design work, and it's possible to get profitable design by focusing on children, on adults, on old people, basically everywhere you have enough customers or potential customers. So, of course, the question is there really innovation in game design or game development? If you go to store today, you see that there's a clones of games that existed 10 years ago, sequels after sequels after sequels, and in fact, there's only a handful of platforms available for development. So, well, of course, the creativity is a really nice publicity stunt. You are free to do what you want, design what you want, and unlike the stuffed up people in software development, you are free to do anything you want in games. So, well, of course there's limitations to that. If you go to a group that makes Medal of Honor games, or FIFA soccer games, have been making them for 15 years, you probably will be making soccer games or football games for the rest of your life there. But of course, there's multiple genres, and all of them more or less can support more products than one. And even actually, there's enough genres that one product cannot possibly fulfill all the customer needs. You can't have a game that fulfills the simulation and strategy game and children's game or, singing game genres at the same time. Also, well, there's themes, there's trends. The zombies were a really big thing a couple of years ago, and the modern war or war simulators have been a large trend for the couple of years. The indie games, meaning that the games that emulate or try to recapture the spirit of the old arcade games, are one thing that's currently hot. And tomorrow it may be something like the cowboys riding dinosaurs example I actually mentioned yesterday. On another lecture, on another course. But anyway, the idea is that what sells today is actually old thing tomorrow. So if you start a company today and go to store and see what's hot today and design that game based on that information, then you might make a nice game, but no one will buy it because it's old news. So there's always someone going through the ideas or themes and stuff like that. So what would we make that's a bit different, that's already in the market, and using creative process or using creativity to create something that's a bit similar, but there's enough differences to get people excited or interested in the product. This is also a bit older chart taken from the same 2011 survey, but this is only to depict that the different categories of games have people or customers interested in them. Keep in mind that the total of this pie here is $65 billion US. So, for example, the action games are 21%, sports in different ways 16%, shooting games, first-person shooters also 16%, family entertainment 9%, role-playing, adventure, racing, and so on and so on. And even the smallest pie here, the arcade games, 0.2%, are still hundreds of millions of dollars. So there is money in all different genres. It's just that you have to find the one thing that the customers are interested in. So, finally, on some summary on the game design. So, the games deliver user experience. Like I have said several times on this presentation, and I cannot emphasize enough the fact that since games are based on abstract constructs and they want to deliver user entertainment, they should be focused on the user experience. So the playability and having fun or having the desired user experience is important, and the technical viewpoint, the traditional viewpoint of software development, is more or less relegated to the role good enough is enough. It runs fast enough, or it just slows down for a couple of seconds when the new level loads, means that we will not do optimization work or rewrite our algorithms to get rid of that loading problem. Unless the publisher says that it's a problem, then we have to get rid of it, but otherwise good enough is enough. So overall, the idea is that the game development, at least from the viewpoint and from the opinions of the people working in games industry, is that the game development is creative work, but it just happens to have software engineering stuff in it. The other way was that it's a software engineering work where you get to at times be creative, but the games industry people more or less believe that it's the creative work first, and you just have to do some software engineering. But however, what is the difference between art and games, or basically anything, the art and anything here, is that games are designed for profit. If you are making games, you are always aiming for profit. The artistic merits and creativity are, they are well-received attributes. They are liked if they exist, but there are still people making the 19th sequel for the FIFA football game, and it keeps the electronic arts in business, so I guess there's money in that work also. There's also people making highly artistic games and making money on that, but nevertheless the money is something that always have to exist. This profit versus merit question was asked from 40 different game development professionals. Game designers, game company owners, game company founders, game developers. That would you like to be involved in a project which gives you merit, makes you famous, but doesn't actually sell that well, meaning that it's an innovative and different, but ultimately not very profitable product? Or would you like to be making the sequel of the sequel of the sequel, which is completely forgotten when the next game, the sequel of the series, comes around, but sells enough so that it actually generates you nice income? Almost everyone said that they would, or in that scenario, always take the project which makes them profit. Only a couple of people said that they would like to be involved in something that brings them merit, but they also used the caveat that, we already have enough money that we can pay for one product which only gives us merit. Or actually, many people said that they would like to be first on the project that gives them profit, and then later be remembered for another project that gives them merit. But nevertheless, the game industry professionals almost always said that the profit is more important than having your artistic vision shown, that or you are known as a great designer for your artistic merit. Well, also, how the games are then designed? Well, brainstorming, vision, pitching contests, prototyping, pen and paper, they are not really that different from software engineering work. There's someone who gets a vision that, okay, this would be a really good idea, then just, drafts up something and tries to sell the idea. Or brainstorming, a group of people tossing around the ball and trying to get idea put together, or pitching contest, meaning that the company or development team is divided into groups and everyone creates and pitches one idea and we select the best one to go forward. Or doing prototypes, just multiple prototypes. And finally, pen and paper, meaning that you get the idea for something and then just draw up a draft for user interface or mock screen-ups or screen captures or things like that. So how the product would look like if it would actually exist. And always marketing and testing is involved. So the design principles are: what is fun, and is this game or is this design fun, or how can this design be funnier, and fun, of course, meaning the desired user experience. So second to last slide here. So if you want to go into games industry, and you want to decide that, okay, this looks that everything works fine. After this course you take the game jam and then you go to the game development crash course and you find yourself with a team of people who actually understand about games and you want to start your own company. So this is the summary of what a normal, typical game startup company looks like. They make their first product for mobile system, smartphone or tablet, because the production values are smaller. There's 2 to 4 people and they work as owners without salary. It means that they own the company, they own the product and they own all the profit, but they are unable to get their salary for the work at that point. It's said that these sort of peoples are funded by 3 F's. Friends, fools, and friends, fools, and fans. Sorry, I forgot what the third F is. Family, yes. Friends, family, and fools, yes. Meaning that if you are stupid enough to give money for the development work for the game startup company, you must trust those people. And actually, several people, even designing very successful startup companies, have said that the most important funding source for their work was their wife's or girlfriend's wallet, because they paid for everything while they were just home developing the game. Anyway, you want to have something published because the big players don't really care about you unless you have a portfolio of things to show. You need a couple of things you can show for example, larger publisher, international publisher, that you can do different genres, or you can do different types of games, or if you are unable to do that, at least you are very good at the one genre or one theme your company does. No one cares about some company who haven't done anything but are thinking that they might do something. Also, the biggest expenses are the tools and the marketing. The tools first, because the professional development tools can be actually quite expensive. If you acquire all the licenses required for commercial development work, for example the 3D Studio or Unity Pro, with all the necessary plugins for developing the different mobile platforms, we are talking about several thousands of euros here. So it's not that cheap. Actually, also marketing is the other one, because like I said earlier, if you don't have marketing, you don't have revenue. There's enough people in the business already, so if you can't do marketing, you are more or less just building your portfolio, trying to sell your team as outsourcing group for someone else. And finally, there's a saying that the three most important problems with the game startup is that they require, first of all, money. Secondly, they require more money. And the third one is that they also need more money after that. That's basically something that everyone says. And if you have the money, then everything else is just, elbow grease, working hours, and sleepless nights. Okay, so that more or less is the how game companies function, or how game companies differ from software developers, or what are the differences and similarities with software companies and game companies. Do anyone have questions regarding this presentation right now? We can start the reviews after that one, after this. Okay, good. I'll just then switch the recording off and we can start with the reviews.